Welcome to Rusty Brain Dump. So this is the Gecko drive, the Gecko 320 G320X, and these are the ones that I'm using in my machine, as you may have seen on my earlier videos. So why am I showing you this? One of the things that I need my machine to do is to be able to enable these drives and disable them when I click the button in LinuxCNC. So they provide a pin for doing that, which is the reset pin, pin number 5. When you pull pin number 5 to plus 5 volts, it will enable the drive. When you pull it to 0 volts or to ground, it will disable the drive. You can do that by connecting it to this encoder plus 5 volts DC or connecting it to the encoder ground. They're all in the same circuit, and that will pull it high or pull it low as necessary. The other part of this is that when you do pull it high, you need to leave it high for about a second and then take off. Then you want to remove that pulling it high, because this is also the error pin. So after the drive is enabled, if this pin goes low without you pulling it low, that means there's been a drive fault, and you can sense that and make decisions in your software based on that. So I want to do all of that stuff. So I came up with a circuit to do that. And let me show you that right here. So here you see the first circuit concept that we came up with. I asked the help of my friend over at Wayne's tinkering page, and he helped me come up with this circuit. Actually, this is his design, and so we tried it out, and it has some flaws. What this circuit does is there's 5 volts connected to this side of an optocoupler. When this side of the optocoupler gets pulled high, it will turn on this side of the optocoupler, which will provide the 5 volts to each of the reset pins on each of the 3 Gecko drives. I can control how long that's on by a microcontroller such as an Arduino. I can set it so that after 1 second it stops providing the 5 volts and the drives will stay enabled. The problem with this circuit that we found is that when you stop providing the 5 volts here, the rest of the circuit here through this other optocoupler provides a path to ground, which acts as a pull down on the reset pins, and it disables the drive immediately. This circuit is a great starting point, but it needed a little bit of work. This is the side that will tell LinuxCNC if one of the drives faults in the middle of usage. So this is the circuit that I came up with. I'm not sure how well you're going to be able to see this in the video, but there's not much different between the circuit that I just showed you and this circuit. Only a couple of minor differences. I use Zener diodes instead of regular diodes because they provide less voltage drop, and I had some problems with getting enough voltage through this optocoupler and the diodes to enable the drives. Secondly, I added in here transistors. These transistors eliminate that path to ground that we had, and so when I enable this transistor, it then enables these optocouplers, which enables me to sense when one of the drives faults. So that's the other thing. In addition to that, this circuit also has another addition to it, which is the circuit that allows me to disable the drive from the software also. So when pin 11 gets pulled high, then it will pull all 3 of the Gecko drives to ground, or their reset pins to ground, which disables the drives. So let's go out to the machine and show you the circuit in action. So here's the circuit that I put together. We have the Arduino right here. We've got, this is the input from LinuxCNC going into pin 11. I think I may have mentioned that earlier. We have these 5 ICs are optocouplers. These 2 ICs here are the bipolar transistors. There's 2 of them on each one of those ICs, so I'm using 3 of those. And then I have the various Zener diodes and other connections that are necessary to make the circuit all work. The rail on the right is 5 volts coming from the encoder 5 volt DC from the Gecko drive, and the rail on the left is 5 volts coming from the PC. So the circuits are isolated. The rail on the left is completely isolated from the rail on the right, and this allows me to enable the drives and disable the drives using the amplifier enable and disable pins on from LinuxCNC. I apologize for all the noise, but the machine is up and running, and I want to show you this working. So as you look at those Gecko drives, you can see that there's a green light and a red light. The red light means that the drive is disabled. I'm going to click the enable button, and when I click the enable button, as you can see, the green light went green and the drives are now enabled and will run. When I disable that same button, the drives are now disabled again. So there you go. Now you can see that it works. Thank you for coming to my channel and watching my videos. Please subscribe, and if you have questions or ideas or comments, please send them my way. Thank you very much.